welcome. I'll be walking around, like probably my co-speakers will do as well, with the poll in the middle. So you want to have sort of interaction, engagement, but so probably we'll keep walking around. For the next hours, I'll take you along what's happening in the AI Hub in Amsterdam, what drives the Amsterdam ecosystem with, well, a lot of labs on a broad variety on topics. I'll definitely do it not alone, because I'm the only one who actually didn't finish this master. So the real content will come from Pascal Wiggers, associate professor at the HVA, University for Applied Science, and Stados, with a difficult last name, and I rehearsed, but Graves. And we'll take you more in depth about an example. Okay, what are we actually doing? What's happening in the Cavo lab? And he will take you along what we're doing. But first, I think credits to Maaike in the room as well, because with the AI Hub and the other Maaike in the back as well, somehow it helps. People with AI in their name tend to, my name is Ike, Maaike. Somehow it helps. Claudia in the back, also AI in her name, sort of responsible for everything that helps with engaging. And anyway, it's somehow, I'm really interested in everyone's names. But a few years ago, Amsterdam was just a bunch of smart people, but no one knew about it. And other cities like Eindhoven, Maastricht, they were pretty good at marketing. So some professors began a little bit like, okay, why do people not see us? We're doing great stuff in all kind of projects, but show us. So they brought in people like Mike and many others to, okay, let's show what we're doing, and we need to have a better profile. And one of the outcomes is a perfect marketing movie.
Imagine a place where solutions of tomorrow come to life. Speech-driven AI to help people with disabilities live independently. Using AI for clean and sustainable streets by detecting different types of garbage in real time. AI to contribute to a more diverse and inclusive fashion industry. In Amsterdam, Europe's living lab, we are working on the responsible AI solutions of the future. As one of the most AI-ready cities globally, in Amsterdam, top research, innovative businesses, talents, world-leading events, and a partnering government all collaborate to address the challenges of tomorrow. Via the collaboration AI Technology for People, we are working on a lot of innovative and impactful projects to improve healthcare with information from data, advance innovation in business, and enhance AI to promote online security and democracy. Are you ready to contribute to the AI solutions of the future in the city where innovation, business spirit, and creativity meet? Join Amsterdam, Europe's living lab, where AI technology comes to life. Imagine.
This gives the vibe of being better than Eindhoven. This is not where we started, but this is where we started with the marketing part. But in the end, it's not about who's got a better promo video or aligning or better marketing slides. In the end, it's about content, and that's why this is the outline for today. I think we're great at a few things in Amsterdam, and I'm taking you along a few of the labs we have. But one of the things I'm really proud of, and my role is being head of innovation and R&D at the City of Amsterdam. And our use, or our goal, is to make sure that in the end, all the research or all the knowledge in all these rooms these days are being applied at City Hall, make use for citizens. That's where Pascal Wiggers comes in. He leads not only responsible AI part for the University of Applied Science, but also brings in with all kind of projects together with other applied universities. How can we actually translate all the knowledge into City Hall? And it goes from AI to support engaging citizen participation to how can we make a more inclusive city for all. Stratos Gavis will take you more in depth what's next in the role of time in machine learning, one of his many things, by the way. So that's why I'm talking pretty fast because I'd like to learn more about their stories. Short. What's the Amsterdam Digital Powerhouse? A lot of slides with the idea we've got scientists in the room, so you prefer slides with text instead of pictures, so you can handle knowledge pretty fast. But we've got a lot of large corporations in the Netherlands who also take huge investments in AI. What we did, and that's where the AI Hub in Amsterdam grew it in the beginning. An example, the national police who said, okay, let's combine research and our knowledge together in the police AI Hub. Ahold, the largest, in the end, food distributor in the Netherlands, worldwide, also pretty on top of the rankings. So okay, let's combine the knowledge of the UvA, in this case, together with the knowledge we have in Ahold. And it's all pretty bold, but in the end it's about, okay, how come Ahold's mission is how can we make people buy more stuff? Well, how do we work together in a lab like this? How does music interfere in a supermarket on your shopping behavior? Those things are being tested in a lab like that. Or how do we smell? How does the supermarket of your future look like? How does all these things come together? Well, what I like about the setup of Amsterdam Digital Powerhouse, how do we combine these experiences, these knowledges? Because, well, as a government, I think you should be able to trust that we don't nudge you that much, like Ahold wants you to, because we like to give you decisions on our own. But the knowledge that's in these labs, well, how can we transfer it to knowledge in society? Well, it's easy to give a huge list of all the labs we're having, but why is it actually working in Amsterdam? Well, huge amount of students, AI startups, a lot of programs, a lot of incubator programs in Amsterdam we can support. So many of you have seen these probably on the floor with all the marketplaces around. We're not good at focus. We're good at a lot of things, but also not. So a lot of topics where you see Amsterdam, it's not only Amsterdam, we're doing it together with the University of Twente or Eindhoven of Maastricht. And I think that's good. In slide decks, it works saying this is Amsterdam, but in practice, it's actually a lot of cities, a lot of universities combined. So most of the labs are not only focused on one university or one aspect, it's about working together. Amsterdam put a lot of focus on health, smart health, one of the main topics. And if you look at the content of these 2 days, you already notice it's about how can we amplify research on cancer? How can we use image recognition to improve medical research? Those are the things we're pretty good at, and that's also, it's not only about the universities itself, it's about the Cancer Institute, it's about St. Quentin, it's the Blood Bank. Those are the main partners or the core partners when we talk about the AI Hub in Amsterdam. So it's on one hand, it's companies with bold ambitions like Philips, Ahold, etc. But it's also how do we connect science with, well, medical use, etc. Amsterdam is pretty small, or at least the Netherlands is pretty small. So most of these things are aligned with the National AI Coalition. And that's where I think that's also pretty effective of working together for the last few years. There are huge investments in a national growth fund to be invested in AI for the last few years in the next upcoming years. So it's not only about Amsterdam positioned in the Netherlands, it's about Amsterdam positioned in Europe, positioned in the world as being, well, one of the hubs to accelerate and innovate. It's so easy to talk a lot about partners while we say, okay, let's move a bit forward about the goals. Well, what we can do as going black made me nervous because that's what can happen with the AI ambitions as well, and that's where we're forward to what should this coalition do? Build an Amsterdam strong digital ecosystem. Well, why would another AI lab, or EKI lab it's called, will be based in Amsterdam? Because we've got power for calculations. We've got, we have to work on that as well. We've got 7,000 students at the moment, but there's way more request for more. We cannot handle it. We don't have enough university professors to actually handle all the courses, etc. So if anyone wants to become a professor, Start as well can guide you probably. But we need that because those are the bottlenecks in growing. So it's not about challenges, etc. It's about actually the whole ecosystem on how we work together. And it's about getting the right people in the right positions, but it's also about access to data, access to computer power, etc. This is the ambition to make sure that we arrange that together. And of course, as I said, this is what we try to shine with, but it's the same in a lot of places, and that's why we work together as well. So, here's a picture of what we do, and it was actually on the cover of the AI Technology for People magazine, and it shows us that it's not only about doing research inside Science Park, which is on top. Sorry, the list of all the labs, it's on the science region in Amsterdam, but it's spread out in the city. It's on every corner where we work. I'll give you 3 examples of labs which are relevant from my perspective. As well, leading the R&D part at City Hall, we want to know if is AI being used ethical or legally correct, or what's the social interference. An example, the Cultural AI Lab is a pretty huge lab, but one of the examples is in Amsterdam we made some choices in history. An example, slavery. How do we think about looking back at our history and what's the correct way of representing our history? The Cultural AI Lab is doing research. Okay, what is actually the best approach to do research? And one small example, if you put 1 million images into a learning system with all women with blonde hair, and there's one with a queen with a crown on her head, the system will never learn that that's actually a queen. So if you want to learn a system, what's actually cultural relevant, you should have some default things. Well, for the queen, it's pretty simple. But if you look at the cultural heritage we have as well, slavery is one of the examples, it's pretty complex. What are the things you put in order? Well, those are the questions being tackled in the Cultural AI Lab. High expectations. The same goes for media and democracy, where we try to tackle fake news, disinformation. How do we make sure that we're not only scared about Russia being invaded our local elections, but what are solutions? Maybe we can go back to it later, but this is where we are. You can be involved as well. Some of you, I know what you're doing. For some of you, I don't. I think it's good to have the general story. I can just send it to you. For the next, I think for Pascal and Stalis, it's good to know a little bit who you are and what you're doing. So can I ask you, what's your role and what are you doing? Knowing this is what Amsterdam does. And next, we hear about applied science and how do we do it. And then we'll go on into the Kuva lab, so more in-depth time learning, machine learning. In that perspective, what's your link with AI in Amsterdam? I live in Haarlem as well, and from this perspective, we count it as Amsterdam as well, because that works better in numbers. For you, what do you do?
I'm Shivan. I work for Cadence, which is a medical AI company for cancer detection in the lungs. My aim is to have a startup which caters into this AI field, and I would like to know what AI initiatives are in Amsterdam area, so that I can
check. At the end, that's as well credits to Mike, who put the whole list of all the labs at the end of the slide deck. So I'll leave them on. We could probably send them around later on what's actually, there's a huge list of people who support the coalition, etc. Later on, there's actually a nice, decent list of what's happening in Amsterdam. But I think regarding time, let's go to content, but there is a list of what we're doing. So what's your profession role connection to here? Then we'll go to Pascal. Yeah?
Oh yeah, I'm also from Haarlem. We have lots of Haarlemmers here. Eh? Yeah, I work together with Pascal in the Responsible AI Lab also, University of Applied Sciences.
Check. Then we'll hear a lot about what your work
You
is.
hear more about that.
You're also Haarlem probably, because the statistics-wise, this should be.
I'm from Haarlem, but I live in Amsterdam now. But I'm the I'm the lab manager of the AI Media and Democracy Lab. So that's why I'm here.
Check. And it's good I skipped that part, so I can't make any mistakes about what's actually happening in the lab. So it's good later on to address. Pascal, can I ask you to continue? Later on, we've got time for questions on where we're heading. I'll be back to guide the Q&A later on, but first content.
Very good. Hi, I'm Pascal. And I will focus on one of these labs that is part of the Amsterdam AI Hub, and it came up several times already, so the AI Media and Democracy Lab. And if you've been here around today and probably yesterday, you've heard in many talks that AI is a transformative technology. I was in a session where they said it can help prevent wildfires. In another session, it was about AI will change the game of tennis completely. And the same holds in the media domain. For media, AI can be a big transformation that will influence how we do journalism. And many of these things are pretty mundane and already familiar, like using a search engine to find background information, recommendation technology that tells us what information we would like, what news articles we find interesting. And a lot might be coming in the near or not so near future, like data analysis to support fact-checking, or synthetic media, or robot journalism, so computers writing or producing content, writing articles, making videos even. And the question, of course, is what does that do to the job of a journalist? What does that do to our interaction with media as consumers? And what does that do for democracy? Since media is the way we get informed and base our decisions on. What if the synthetic media becomes big? That can be an interesting way to go. But it also means fake news, probably, deep fakes that we cannot see if they're real or fake. So how does that influence democracy? And that's what this lab is all about. So with all these new transformations, we actually come in an area of new choices. To give a little anecdote of our colleague Nathalie Helberger, who's also in the lab, she talked to someone from a media company who said, well, if we can detect that our viewer has been watching television for 3 hours at a row, what are we supposed to do? Push more content, promote binge watching, or do we actually have a responsibility to interfere and to warn this person, maybe you should turn off your TV? Or should we stay neutral? But can you be neutral? And that's exactly the point. Technology brings ethical, legal, social choices, which is why the AI Media and Democracy Lab is an ELSA lab focusing on these aspects. And it also nicely illustrates, and that's where we start from, that technology does not overcome us. It's not something that happens, but it's up to us to turn it in what we would like it to be. But to make sure that our media and democracy are the way we would like them to be, we all have to act. It's not just the technologists, but also the journalists, the editors, but also society at large. And starting from there, we founded the AI Media and Democracy Lab. Because to do that, you need to be multidisciplinary. You need to have many different views. So the lab founders are 3 of the knowledge institutes in Amsterdam. The Amsterdam University at the bottom, the Amsterdam University of Applied Sciences at the top, and the CWI in the middle, where the University of Amsterdam brings in knowledge of law making, of social sciences, while CWI does computer science, fundamental computer science. And then finally, I'm from the Amsterdam University of Applied Sciences. we translate fundamental findings to practice, test them out in practice, and actually look into how do you design systems. And bringing all these perspectives together can help us to better understand the impact of technology in the media domain. But then, of course, that's only part of the story, because when I talk about the media domain, you also need media partners. Oh, that's us, by the way. Don't look at it too long. I was saying we also have media partners. If Haarlem is Amsterdam, then Hilversum is also Amsterdam. So then most of the media companies in the Netherlands are in the Amsterdam area. The big newspapers, the television companies, and many others. So here you see your partners. Part is media companies, also international. BBC is at the top. And part of it is government, since we're also interested in the democracy aspect of media. And the way we work in the lab is that those are the companies or the people who state the problems. They tell us what is up next and where are the issues. So that's not an academic exercise, it's a practical exercise. And from there, we start our research. And what we do is we create sandboxes, so safe environments to test new technology, preferably together with developers from these companies, with journalists. And once we get a grasp on what it does, we try to actually test it out, evaluate it in practice. And by doing that on multiple projects, in multiple iterations, we hope to extract fundamental scientific knowledge. Are there underlying principles that we can reuse in other contexts? So the lab has, I think, 5 or 6 years, I have to look at Sarah, of funding to actually go through this cycle multiple times. And then we focus on several bigger themes within this domain. So on one hand, over here, there's the newsroom of the future. So what would a newsroom look like in, say, 10 years? What kind of technology will people use? How will journalists work? That's what we try to find out there. We're also looking into the audience with the relationship, into novel ways to communicate, for example, through avatars, virtual chatbots. But we also look at ways to measure audience engagement and go beyond the typical how often did you click or how often did you scroll type of measurements. And then there's the question of how does the law play into that? How does the new European lawmaking work out in the media domain? So that's what we do in the governing AI in the media. And can we help media to create legal and ethical boundaries to what they're doing? And then finally, that's always a bit of a strange title, that is Making the News with AI, in which we really dive into algorithms that help us shape or understand newsmaking. And I have 2 examples. So one of the bigger topics within that Making the News with AI, on which all the knowledge institutes that I showed are working, is the question on how can we make recommendation technology more diverse. So recommendation technology, that's what happens when you watch Netflix. It shows you if you like this, you would also like that. And that's very good at showing you more of the same. But you would actually also have people to see stuff outside their familiar bubble, things that you would usually not watch to broaden your scope, so to say, or at least make sure that it does not get too narrow and that you focus only on this little field of information that you like, which is especially important when it's about politics, for example. What if you would only see a news that fits your political view and not the other side anymore? So we are looking into how can you make recommendation diverse enough. And one of the tools that we made is a tool to actually see if a recommendation algorithm is creating this filter bubble, this tunnel vision. And Marcio, sitting over there, is actually the author of this tool, so all credits go to him. But it turns out that it's really difficult to measure, since a recommendation algorithm depends on the behavior of all people involved. So if you have watched a number of movies, for example, and I've watched similar movies, then the recommendation algorithm will use your information to give me a recommendation. You like this, and something else that I did not watch yet that might be interesting for me. So it quickly becomes complicated. If you do that for thousands of people, all the information is interacting. So to get a grip on what the algorithm does, we built a simulation with simulated users in which you can insert any recommendation algorithm and then let the computer play it out. And these simulated users, that's what you see at the side, I know it's unreadable, are properties. How often will people click on something that has been recommended? How often will people search for information themselves? And that's all probabilistic. So say 60% of the time I will click on a recommended algorithm. Will I read something shared by my friends? How often will I do that? And by tweaking these settings, we can see how such an algorithm plays out. And it's a bit, maybe the picture is a bit difficult, but it's on the axis you see two news items. So one could be about COVID, the other about the war in Ukraine, for example. And the position on the axis is your stance toward it. Is it positive or negative? Or neutral, or somewhere along that line. So maybe my two news examples weren't too good, actually. So what you see here is all these green dots are people, and they have a particular position towards both of these topics on this picture. But in reality, of course, there would be many more topics. And then by reading information, they might change their opinion a bit. So you might become more positive or more negative towards a particular item. And if the recommender is not interfering, so if people get diverse information, the cloud of people will also be very diverse. But here we tweak the algorithms in such a way that people started reading only the type of information they already knew, they already liked, and they shared with their friends information that they and their friends found important. So for example, I'm pro-COVID or against COVID, but not the other side anymore. And what you then see is then you see actually these filter bubbles appearing. Marcio can tell you all the details, but the point is once you have this, you can also see how can I interfere? How can I change this to make sure that this will not happen? So that's one example. And the other is fake news, is a big topic we look into. And fake news and AI is an interesting combination because on one hand, AI can be a source of fake news. You can use it to automatically create content. You can use it to distribute content, making Twitter bots, for example. But you can also use it to recognize it, to classify fake news. And in the lab, we are interested in basically in this question from different angles. So we would also like to know, where does it come from? Why is it spreading faster than factual news? Or at least that seems to be the case. And what can we do to make people more resilient? So that's more a social science approach. But also, can we build tools to recognize it? So what we did is we built one tool that can recognize fake tweets. And there's a tweet on the screen right now. It says the National Science Foundation, so it's in America, spent 1.2 million paying seniors to play World of Warcraft to study the impact it had on their brains. So I would like to play a little game with you, see if you can recognize fake news. So who thinks this is fake? So that's a minority. Who thinks it's true? This happened. And then I've not seen all hands, so there are also people who are undecided. So who's undecided? I'm still missing some hands, so that's, okay, interesting. So conclusion, as a group, you are a bit undecided. I think that the most hands said fake, and then true came close. And in fact, it's very difficult to do this, unless you know the topic very well. So even if so what we did is we did crowdsourcing. So what I just did with you, but with a bigger group, ask people, what do you think? And you see that the results are, well, say close to what we just did. So most people said either false or mostly true. And then there were a minority that said true and a small group that was somewhere in between. So once again, no conclusion. We also asked an expert, which somehow disappeared from my slide, but the expert said it's false. So the people who said false were right. And we asked the AI. So what you see here is the result of the AI model, who also said it's false. And what we try to do here is to let the AI explain how it arrived at this conclusion. Because you can build an AI that can understand fake news, but then you would like to know how it does that. Or is the AI itself biased, and might it introduce errors rather than solve them? What you see here is a typical way to visualize explanations of an AI system, a self-learning system. So word by word, it marks whether it's true or false, an indication. So blue means it's an indication for true, red it means it's an indication for false. And basically, it's the amount of money that the computer thinks is shaky. Not even the fact that they pay elderly to play World of Warcraft, which in itself is a strange fact, but it's the large amount of money, basically, that worries the computer. And indeed, that's correct in this particular case, but more often the computer has it wrong. So it's not that good at predicting fake news yet. And maybe it's not that useful to have a computer predicting fake news, but rather to build tools that can help you in fact-checking, that can help people to better understand fake news. I think that was your question?
Yeah, this looks at the sentence and the words. Oh, sorry. This looks at the sentence and the words that are used and kind of insinuates that people who write fake news write differently than people who write true news.
Which in itself is not a wrong assumption. Fake news is often more exciting than real news. But of course, if people who write fake news know that this exists, they will adapt.
Yeah, right.
So there are other ways which I have not shown. You can also look at how it spread through a network. Was the same news item tweeted by 1,000 people at the same time? Then these people are probably bots rather than people. And that's a more stable feature than just looking at the words.
Thank you.
The AI is not that smart at all. It just has learned to look at large amounts of text, and it will look at the wording, and based on that come to a classification. And the difficulty is that the explanation is no better than this. So in fact, I don't know what's going on in the model other than what it shows me here, which is worrisome to some extent. But that's exactly what we're working on. I think I'm running out of time. And I was at my final slide where I just wanted to say, to do all this, I said you need a place to experiment, and we have a physical place to do so and to meet each other. And I think that's a very important part of the lab. So AI is all virtual, but you need physical collaboration from multiple perspectives to actually address all these issues. Thank you.
Already some questions, but another question for Pascal. Check.
So to what degree would you consider the output that we see from the AI more useful than the crowdsourcing prediction or the crowdsourcing opinion that was being presented?
I'm not sure that I do, but the advantage, of course, is that you can do it at scale. AI can look at thousands and millions of messages, and the crowd cannot.
The thing is, as you also mentioned, the main, let's say, the comparison that we can take here is from the meaning that the AI is taking about the money, which was actually an important factor. But the thing is that we actually take consider important is the fact of senior and Warcraft. I think that is the more logical thing to consider. However, at the other side, I am seeing that the AI is paying attention to something that we humans don't. So that could add to what already we do not understand. But at the same time, it is also important for us to make an input for the AI of what kind of logic we already think is important. But that is what is already lacking in fake news detection.
That's correct, yeah. I think an important area to look into is how to better make these visualizations, indeed to inform people, okay, this might be relevant.
Exactly.
Rather than say it's false or true.
Yeah, exactly. So in comparison to just dichotomization,
exactly.
we can just say, okay, to what degree would we think? I think that would be a better kind of a libertarian, paternalistic kind of a behavior.
I think what we try in the lab is say to data journalists what kind of output would actually help you, which is not false or true or something in between. But it's up to them to tell us what should that look like. And from there we will see how can we build the AI.
I think the room was also sort of an invitation to join build the next step.
Definitely.
That's why I shoot a picture. So, and another one, I know Pascal a bit longer, that he actually responds to mails and questions and stuff. So if you take more time to think about it, you can always ask him. Thank you very much. So that was good. I know for a shorter time, but I know that the one link we've got is that one of his former students, now his colleague from the one in the back.
Yes.
And what he liked is actually you should try to prove him wrong. So listen carefully, and I know he enjoys people fact check, in this case, if he actually has a comprehensive story. And how people in the room are actually listening, so enjoy.
All right, well, thank you very much. It's an honor to be here and talk in front of you, and I'm very happy to see very familiar faces as well. I do love people telling me I'm wrong, means that I'm in the right room. So yeah, if you find mistakes or if you disagree, just tell me or interrupt me. So I am Efstratios Gaves, that's like my full long Greek name, but I use that when I go to the police. Otherwise, you can call me Stratis. And today I'm going to talk about the machine learning of time and dynamics, which is my area of research, as well as what AI means for Amsterdam and the University of Amsterdam. So very quickly who I am, because I'm sure most of you don't know me. I'm an associate professor at the University of Amsterdam. I am ERC starting grant and NVLVD laureate. That's like the two top scientific grants in Europe and Netherlands for fundamental science. I'm a co-director of the CUVA lab with Qualcomm and Pop Art lab with the Netherlands Cancer Institute and Electa for using AI in adaptive radiotherapy. I'm teaching deep learning 1 and 2 in the master's level, Masters of AI at the UVA and an NL Scholar. Also, I'm a co-founder of Elagon AI for oncology, and I'm going to discuss this a bit further later down in the presentation. Maybe this is a good moment to, since we're looking for professors, we're looking for an assistant professor for the Pop Art lab. So if you're interested, let me know. Right. So AI is actually a fascinating area of research. I mean, you're all here to hear more about it. What is deep learning, deep AI today? Well, you got this, I don't know if you've ever seen this like page, like this picture before. It sort of summarizes visually the most popular architectures out there. you see a lot of commonalities, right? It's like neural networks. It's networks. Different colors correspond to different types of functionalities, but at the end of the day, they're all more or less the same. And what drives that? Why does it work so well? Well, one thing is big data. Without big data, you cannot have big AI. That is, you can take this for a fact. And the fact that now we do have big data, well, not just now, but let's say 10 years ago with ImageNet or some other competitions, this is how AI became super popular. Another reason why AI is specifically now, or in the last 10 years, very relevant is big compute. So NVIDIA has created, initially for a different purpose, like very different purpose, some specialized architecture, some specialized hardware that enabled the fast training of AI. So you could then use very complex neural architectures on very big data in a reasonable amount of time. But it's not just that. We have smart algorithms. Oops. We got smart algorithms, and while it is certainly true that up to 2010, mostly the algorithms that we're using were quite old by now. You know, the old algorithms were working pretty well once you start using them with big data and big compute, right? But that said, we have to be also fair and say that there were tremendous algorithmic advances in the last 10 years that were not possible before for various reasons. And what is becoming increasingly clearer and clearer is that we need the right amount of inductive bias. What does this mean? It means that it's a very big mistake to think that we just throw data into a model, we run it in our cloud, and that will magically work. No, AI is not a technology which is magic. It might sound magic, it might be very complex or less complex depending on each person's background. However, it's not magic. You need to know, you need to have specific knowledge about the domain you're applying it to. Otherwise, likely it will not work, or anyways, you cannot have guarantees. Now, the past years have been the golden age of learning algorithms. And well, I started my PhD in 2008. And back then, the landscape was completely different. So I don't know if you've ever done that, like my primary area of research was computer vision, and we had a top left picture of Pascal VOC, or MS Coco, I think. And then the goal was to localize objects, to basically say each pixel what object category it belongs to. For instance, pedestrian, bicycle, trees. Back then, the accuracy of algorithms was about 32% in mean average precision. That was with the deformable part models with Felsenswalb, and with Jasper Aulnick's and Arnold Smolders using Bago words model. So this Jasper and Arnold was my supervisor and fellow PhD student. So we had actually, even back then, we had one of the leading teams on AI on a very relevant problem. However, the accuracy was 32%, and we're extremely happy. We thought okay, you can't do better. Now, on much more complicated data sets, the accuracies reach routinely above 90%. There's a paradigm shift there. We've got now learning algorithms that they cannot just detect objects, but they can even narrate scenery. You put a picture, and then the algorithm will tell you what's happening. At the same time, we have algorithms that they were able to beat Lee Sedol, who was the 18 years world champion in the game of Go, one of the hardest, like after chess. And quite importantly, I don't know if you've heard of that, but I think 1.5 years ago, DeepMind, so the company who built also the AlphaGo, delivered the AlphaFold algorithm, which was able to model protein folding. Now, protein folding was perhaps one of the hardest challenges in biomedical sciences. Basically, the idea is that given the input of amino acids, can you predict the 3D structure, how things will interact? And one would tell you, like, come on, that's like just simple physics. You just compute the powers, the van der Waals and whatever, and then you compute like how things fold. But no, that was really not how things are much more complicated once you start putting things, complex things together. Now, what is super amazing is that all these were solved basically with the same algorithm. These neural networks that I show you in the previous page, in the previous slide. So the same algorithm, same family of algorithms managed to solve really heterogeneous, really different types of problems, really different types of tasks. And this brings me to, like the beginning of my research. What makes me, what interests me. I believe that there is an urgent paradox. Can AI recognize, for instance, an apple falling? And I'm here to tell you that it cannot, or it cannot do that really that well. So, for instance, in own experiments, as well as experiments from other researchers, we found out that whether videos, let me see, whether videos move normally or they're reversed, basically the result of the algorithm is pretty much the same thing. It doesn't make a difference. And why is that important? Because real world data is largely space stable. For instance, you've got here the video of a truck coming, and then there's a kid crossing the street. The truck couldn't be able to see it, and then you'd like your truck, if it's autonomous, or even if it's not autonomous, if it's just like you're using AI as assistants, you would like to predict what's going to happen in the future. And you cannot do that unless you understand something about time. Now, why do we want that? Well, time, in my opinion, is everywhere, everywhere. And right now, machine learning, AI, sort of ignores this, chooses to ignore it for various reasons. But that I'm not going to go into too much detail on that. However, time is really critical, especially when we go to very deep and complex processes. So, for instance, in robotics, in causality, autonomous driving, in engineering and simulations, aerodynamics or water dike floods or jet flows, you'd like to be able to use AI there to scale up the processes, which are otherwise very complex and very time-consuming. Or in sciences, all this, or not all, but most or a lot of data are basically of spatial temporal nature. We would like to be able to predict how and when, for instance, the icebergs will start melting, or how the various biomedical sequences will evolve, how galaxies move, and so forth. So we cannot do that unless our AI becomes more time knowledgeable. So what drives my research is what's the role of time in AI, and my vision is to have AI, temporal AI, which builds in dynamics, causality, temporality, in multi-scale entangled space-time sequences. And what does this mean? For instance, when you got the video of a car moving, then the features, the characterizations that the AI gives are proportional to the type of motion and type of change. So, for instance, if the video would change in the reverse order, you would like to have reverse features. And if it would go slower, you would like your features to be also slower. And this is not actually what AI is capable of doing right now. I'm going to present very quickly one work that I've done in the context of Kuva Lab and Qualcomm regarding the matter. That is on efficient neural causal discovery without acyclistic constraints, and it was presented in ICLR, which is the foremost place to publish scientific results on AI. And the work was together with Philip Lippe and Taco Cohen. Philip is a student of mine. Taco works, he's senior AI engineer at Qualcomm. Now, what is causality? What is causal? Why do we want causal? Like, that's a very important notion. So, for instance, here I've got a picture of there's a chart, and we've got like various countries, how much chocolate they consume and how many Nobel Prizes they've won so far, and you actually see a very linear trend, right? So basically, what this means is that, yeah, in Greece or in the Netherlands, if you want to get more Nobel Prizes, you should give more chocolate to people, and then, you know, that's it. But obviously, that's a false, a ludicrous, an absurd conclusion. You want causality, you want causal relations, you don't want correlations. And what AI so far has been doing is correlations. That's literally what, it's very advanced correlation learning. Now, what is causal discovery? Let's say we have a system with known variables. A system is basically, you know, how you collect your data. So for instance, let's say you've got records, patient records, and then does the patient smoke? That's one variable. Or does the patient have cancer or not? Do they have heavy breathing, family history, and so forth? Now, we've got the system with known variables. We have observations, so we know, like this patient smokes or not, or has heavy breathing or not, and so forth. Also, we can intervene, so we can ask the patient to not smoke. Not always, however, right? Like, we cannot change the genome of a patient, so we cannot change the family history of a patient. And causal discovery is learning the causal relationships between variables. So for instance, does the fact that you've got your patient smoking cause heavy breathing? Yes or no? Discovering all these causal relationships in your graph, that's causal discovery, and it's a very fundamental task, objective for AI. The thing is that modern algorithms scale quite poorly, and in this work what we do is we marry classical causality, which is not my area of expertise. It's very mathematical, so that's not what I'm doing, with neural networks, which is what I'm doing, and neural networks can make things scale. So what we do here is, well, I'm not going to go into the details, but basically we split the problem into two parts: the distribution fitting, where we try to find the probability of one thing happening given everything else, and then graph fitting, so proposing various different types of graphs that you know, like maximize our likelihood and our data given the distributions we have learned. And our algorithm scales up really well. We can easily go up to 1,000 nodes, so 1,000 of those variables, without much trouble. So we're the green line there, which is pretty much flat. And on average with very few mistakes, and at the same time it works really well also on realistic data settings. And realistic is in quotes because these things are extremely hard to actually evaluate in like let's say laboratory environments. You know, you have to go out there and use it. Otherwise, you cannot make interventions. You cannot like collect this data. However, in these synthetic, these stoic settings, it does work really well. The caveat being that we have to take this with you know, a pinch of salt, because there might be some sort of bias in the data that, you know, synthetic bias that lures. So why would we care? Causality is one of the hardest challenges. It's truly hard. If you think about it, causality is, like, whenever I actually ask somebody, you know, why do you do this, they usually come up with an explanation after the fact, after they've done it. And that's actually a very big problem. Causality is very hard to grasp in general, and certainly it's very important for scientific discovery. I mean, you want to know what causes what, and our algorithm seems to do quite well. So in general, I'm sure I'm not the first to say this in this summit, we have an opportunity. AI does have a transformative effect, and quite like funnily, I mean, you just mentioned the transformative, or you just mentioned the transformative word. That was completely by coincidence. Like, so that's like a slide from my previous talks. It does have this, like, and I'm not kidding you. I'm not giving you a sales pitch now. I've seen this. I'm saying this like here and there. And why is that? Because we're getting better and better. We're truly getting better at it. We're not perfect. In fact, I don't think we have yet a very persuasive like go to application to say, okay, AI has really done this and has done this really well. Not yet, but we're getting closer. And why is that? Because every measurement now is, every data point is digital. It's digital, it's recorded. Like all our devices now for creating data is digital. It was not like that 10 years ago or 20 years ago. Now everything is recorded. And we have also strong interest for interdisciplinarity. AI researchers want to work with other scientists, with other interested parties, and other interested parties want to work with AI researchers. So in my opinion, AI will be the new transistor. So I don't know if you've thought about it, but we had the microscope in the 1600s, which basically enabled us to see beyond the world of, that was capable with our eyes. So it opened up new capabilities of looking at really, really tiny things. And the 50s, we had the transistor, which helped us compute things that the human brain couldn't compute in a reasonable time. So again, it unlocked the capability for humans, like to be used as a tool, And I think this is what AI's, purpose is as well, or one of the main purposes. It will be the new data transistor. Like we've got so many terabytes, petabytes of data, literally things that nobody will open, right? Like it's impossible, unfathomable. But AI can help derive insights, can help crunch these numbers to give you conclusions. So I believe that will bring a paradigm shift in science, engineering, and society, and it's very important to do this, to realize this quickly. Whoever does this quicker, they will be the winner in the next few decades. So, as a matter of fact, I have a spin-off on this, Elogon AI, which is has the mission to select the right patient for immunotherapy, like in oncology, with artificial intelligence. So, for instance, if we have an H&E biopsy from a cancer patient, we can predict whether this patient will respond well to immunotherapy or not. Immunotherapy is a Nobel-winning treatment back in 2018 that has shown to be very effective, but not for all patients. And the thing is that, again, doctors, like these are huge images. These are huge images, like the fact, like, I don't know, a picture of a galaxy, and if I ask you, like, count how many planets or stars you see, that would be impossible for you. At the best, you can do like a rough estimate, which will be grossly wrong most of the times. And this is what we're doing there. And we're looking for a senior AI engineer to lead the team. So if you're interested, let me know. Now, to wrap up, what is our place in the world? Here is Europe, and Amsterdam is known for a lot of things: cheese, beer, windmills, nice houses that are ready to fall. So yeah, very nice things. I believe that Amsterdam can and will be the next AI capital. Again, it's not a sales pitch. I'm really telling you, Amsterdam is one of the leading centers for AI in Europe, at least. There's a few more. There's London, there's Paris, there's Tübingen in Germany. Amsterdam can be really is a gravitational center for various factors. But it needs push. We're not completely there yet. Why? Well, we've got the LS Amsterdam. It's for excellence in AI. We're one of the main units that initiated this program for exchanging, elite AI researchers in Europe. And we've got the ICAI labs that were just mentioned earlier. And it's a way to set up labs between industry and academia to do fundamental and applied research on artificial intelligence. Some fruit of this labor, the Kuva lab that I am co-directing, as well as the Poppard lab. There's AIM lab, there's Delta lab with Bosch, supported by the University of Amsterdam, and other, let's say, public organizations like the Dutch Cancer Institute or Gemeente Amsterdam. Qualcomm and Elekta fund these labs. Google and Microsoft do not have a lab, as far as I know yet, but they're actively in conversation. So there are huge players in technology and AI that are interested or have already invested in AI. But is that enough? No, because this is just the beginning. We have great competition all around the world. And to keep it up there, we have to, push more. So my call for action, like my last slide, I believe temporality, dynamics, causality will be the next AI frontier. We cannot solve the remaining crucial 2, 3, 4, 5% to get AI really working out there in a reliable way. I believe that with focus and support, Amsterdam will be the next AI center. It already is something like that. And ELIS and ICAI will be the vehicle. If you're interested in any of the things that I discussed today, this is my email, and you can also find me on LinkedIn or Twitter. Thank you.
I wanted to say we're out of time, but I want to say time is not relevant, but it is. But for people who want to run to another session, please go. But I think some might have a question, so everyone stay. But if you already wanted to go to another session, we're late. So run. So we won't look at why you're running. For the rest, I assume there's some questions. Yes. Guido, Laurens, sorry.
Hi, Stratus. Good to have a lecture of you again.
Very nice.
So I was wondering, you started with computer vision is all based on correlations. I don't have to explain you that. So why is causality so important for time if we look in all of this?
So when you're having static images, you don't really need causality, in my opinion. But let's say you've got moving images, like if for a robot, I want to be able to know what will happen if I push the button, that this will cause the light to turn on, or that if I push a person, they might hit or get injured. So causality is actually fundamental. You can bake all these rules in, hopefully simply with data. That could be a hope, but that's not enough. You actually need to see a cause and effect after intervention, in my opinion, to recognize the patterns that are meaningful, that are not just correlation. So for instance, if I push a person and then they fall, does the fall cause my push or the push cause the fall? This is not obvious. And of course you can hand code these things, but generally the more hand coding we do, the more brittle the system become.
Okay, cool. And can I ask one more question?
Yeah, I see you looking like
that
was scanning the whole city of Amsterdam and trying to
this is my opportunity.
With computer vision and everything. So it's like, okay, maybe I have to adjust someone in projects. Yeah.
So I'm also wondering, so these 82% that you showed, I think that's working now. Is this with like inductive biases, like LSTMs and those kind of mechanisms?
Yeah.
So how does it come that those kind of mechanisms are not working good enough for?
I mean, that's, I think, a more technical conversation we can have. I think for LSTMs, the reason is that they've got a very chaotic behavior, and then the optimization sort of boils down to learning weird averages between frames. So it doesn't matter what's the order of the frames, the result will be the same, because that's the best the model does. So basically, it's like, it's the same like when I give a very hard task to my employee and then they, whatever, like they do something, they don't even care after a while. And that's what the LSTM does. So it does something, like it overfits, it finds a pattern that sort of works, and it doesn't care for the more complex thing that it should normally do.
Okay. Thanks.
Cheers.
Another question?
Yes. I was just curious, what do you think is the role for social sciences in advancing this? I think everybody can hear me, right? Yeah. Okay.
So if you want to rephrase your question, because now you know it's recorded.
Because everything needs to be recorded. Yeah. No, I'm just curious, what do you think is the role for social scientists in advancing AI? Because you also, also at this summit hear a lot of concerns also with the technical aspects. And myself as a sociologist, does feel a bit distant, the technical part sometimes. You feel like you're only in a reflective role, but say you want to be more constructive, what would be a constructive role you think for social sciences?
First of all, I think that's a great question. I believe social sciences is basically the fundamentals of science. That's how sciences started to begin with. And I think this has to be really taken into account. I don't think that social sciences have input into the development of AI, but even further, I believe that social sciences have a very pivotal role in how AI is perceived by society. For instance, I don't know if you know the Moral Machine from MIT. It's a website which gives the opportunity to people to decide, like in case of an accident, which of the two outcomes is least like desirable. So like, are you going to run over an old lady or an old kid? Let's say you've got, right? And this already puts things in some sort of perspective. Different societies have, or different cultures have different ways of addressing these questions, right? So in my opinion, social scientists should then exactly try to understand how AI basically influences the way that people will be using it. And I think that's actually a very important thing. So the main difference that I see between AI and nuclear energy, for instance, is that nuclear energy does not enter your household. I mean, of course, you might be using it in terms of power, like electricity and so forth, but you're not going to have a nuclear reactor. However, AI is a household technology. Like, you use it literally every time, and whether you like it or not, it doesn't matter, actually. Because I can guarantee you that somebody will be running an AI algorithm very soon on everything around. So this creates a problem that the problems of AI, you can see them around very easily. They get magnified. And in my opinion, social scientists are really important there to understand how we can mitigate this, how to improve this, how to fix it. And yeah, that's my opinion.
We're going to wrap up. Thanks. Thanks for your attention. There is a factor of time, indeed. We have to close up. Thanks for your attention. Enjoy next sessions.